Dr. Georg Northoff, welcome to Shrink Wrap Radio.
Yeah, hello. Thank you very much for introducing.
Yeah, well, I'm glad to have you here. And I'm especially pleased to have you on the show because of your credentials as a philosopher. I know we won't get into this, but I had run across the notion of applied philosophy and people who are essentially functioning as counselors or psychotherapists whose credentials were applied philosopher. And so that's something I've meant to look into. However, I think your direction, your expertise is quite different than that.
Yeah, I mean, I am a philosopher, neuroscientist, and psychiatrist. You can see already by the triangle of my education and also the work I'm doing. And applied philosophy would mean a very different sense in my context. It would really mean that I try to bring in some empirical evidence, which we gather in sciences, and I try to link that with the kind of questions you have in philosophy, which usually concern questions of knowledge, what can we know, epistemological questions, and knowledge of existence and reality, ontology, and metaphysics. And of course, there are also other domains of philosophy. And I'm basically trying not really something new. When you look back into the history of philosophy,
Right.
beginning of modernity, people like Descartes, Spinoza, Leibniz, Kant, always linked the conceptual, the ontological with the empirical. It's only in the 20th century that the two really diverge from each other.
Uh-huh.
I'm trying to bridge the gap, and the bridge is, of course, the brain.
Yes. Now, as you pointed out, you've got degrees in psychiatry, neuroscience, philosophy. In what order did you get those degrees? Which came first?
See, at my time, there was no neuroscience yet. So when I finished high school, beginning of the 80s, there was no neuroscience program yet. Probably the young people cannot even imagine that because it's so evident these days. It's completely natural.
Right.
So in order to deal with the brain, you had to study medicine. So that's why I studied medicine, but I always wanted to study philosophy. And I never wanted to study philosophy alone without a science. So probably nowadays I would have studied philosophy and neuroscience, but at the time I studied philosophy and medicine. I did this parallel. And when you finish medicine, you have to do some kind of residency, because otherwise your degree is worthless. So what is closest to the brain? It's psychiatry. And then I became a psychiatrist. And then I continued all three, and now I don't care anymore about the discipline.
Now, some people might wonder, well, what's the relevance of philosophy in today's scientific world? Science tells us everything. Why do we need philosophy? Of course, I don't think that, but...
Yeah, good question. I start with a sentence by Albert Einstein. You only see what your theory tells you, meaning your theory and your concept dictates how and what you see and observe in your science. And every good scientist in the history and nowadays knows that data, empirical facts, experiments go closely hand in hand with concepts, theories, and certain presuppositions.
Okay.
The real progress in science comes when you combine the two. So that's a general statement. Now, with regard to the brain, we currently really, many fellow neuroscientists of me probably might contradict, but nevertheless, we don't really know how this brain works. Okay. In the case of the heart, we really know it's a pump, and it pumps blood. That's the purpose of the heart, and everything revolves around it. And once you know, then it's very easy to know, okay, it's a muscle structure, and it's pumping, and all of that. In the case of the brain, we don't really know yet. And so what you need to develop is different models and theories of brain, and then the corresponding empirical experiments.
Okay.
And that's what we're trying to do.
Would it be fair to say that philosophy is good at generating the questions and science is good at testing out alternative answers? Or is that too simple?
If you want to bring it down, one can probably say it like that.
Yeah.
I think I cannot generate a proper question without some empirical data, and I cannot have an answer without a proper concept or theory.
Ah,
So
so they kind of interlock. We need them
it's
both.
really going back and forth. It's an iterative movement. So the one, and I can see this here, I see certain empirical data which we generate, then I have certain theories and philosophy, then I go back, okay, this requires this and this kind of experiment, and it goes constantly back and forth in an iterative movement.
Okay. And your book really portrays that because it goes back and forth between what the classical philosophers had to say about such questions as mind, consciousness, self, and what contemporary philosophers who are still wrestling with some of those same very basic issues, what they have to say. And one of the issues that you bring up and that runs throughout the book gets at what you were just saying about the heart versus the brain. The hard question, the hard question. It's funny, just preparing for this interview, just yesterday in the New York Times, there was a whole article about the hard question and about a neuroscience conference, one that had happened in New York, one that had happened in Tucson, where people were talking about the hard question. So bring our listeners up to speed here. What do you mean by the hard question?
So the hard question or hard problem, as it is often called the philosophers, so why is there consciousness at all? So why does consciousness exist rather than non-consciousness? So we could also imagine a brain maybe exactly the same way as ours without consciousness. So this is often called the zombie argument. Could be a zombie. And the question, what makes a difference between consciousness and unconsciousness? But this is where it already starts. You can understand the hard problem in a philosophical way and in a scientific way.
Yeah.
In scientific way, it's basically the question for the kind of mechanism by means of which an unconscious state transforms into a conscious state. That's what the neuroscientists call neurocorrelates of consciousness. The philosophers, of course, want much more. They want to say, how is it possible that we have consciousness at all rather than non-consciousness? So
Yes.
that includes also an unconscious state, because the unconscious state can transform into a conscious state.
Yeah.
So,
So you point out we can look at the objective brain. We can see that there are neurons and white matter and so on. So we can see all of these objective things to our senses, but what we refer to as mind or consciousness, that subjective experience, we can't see.
yeah, I mean, that's one of the
Except in ourselves.
except for us, this is one of the backdrops against which the hard problem is set. Yeah, what we observe from the outside in an objective way is the brain. That what we see in the functional brain images, you will never see consciousness or what the philosophers like to call qualia, the subjective qualities, a certain what it is like of color experience, whereas experience and consciousness is intrinsically subjective. Yeah, you cannot share your consciousness of boredom about my answers. I don't feel your boredom or the listener's boredom when they listen to me. Yeah, I can maybe see it in the face, but I cannot experience it. I cannot feel it.
Yes.
And that's really the big philosophical backdrop. And so there's an objective view on the brain and a subjective view of consciousness. How can we reconcile them?
Yeah.
So there's a lot of conceptual work to be done, a lot of philosophical heritage.
Now, the title of your book is Neuro-Philosophy and the Healthy Mind, Learning from the Unwell Brain. And what you propose there for your task is to look at broken brains, people who have neurological problems of one sort or another, and from that to deduce the various elements of consciousness, what's lost when there's brain damage. And in a way, that strikes me as an old approach, right? Isn't that? And in a way, I would have thought that was surprising to me at first, because I would have thought, oh, don't we already know all that stuff? I mean, we have all these neurological problems, and that's how we've learned a lot about the brain. What causes you to feel that you can find out more through that
So
approach?
Of course, you're right. It's really an old, that's the way neuroscience got off the ground at the beginning of the 20th century. And I start the book with that, with the Broca lesion, the Broca, the language
Yes.
center in the brain. What we haven't really understood yet, and these are paradigmatic disorders of the mind, are psychotic disorders. We have no idea where and why people become schizophrenic, meaning they show auditory hallucinations, they hear voices, they have delusions, they feel persecuted, they suddenly feel that they are another person in the most extreme cases. So I have encountered many Jesuses. In China, actually, you encounter people who think they are Mao, the former president over there.
Yeah, interesting.
The kind of identity you take on is context dependent. So, and we have no idea. Depression, why you're seriously depressed, sad, you have to think, you have to take your own life on, you develop suicidal ideation. Or the opposite, mania, we call it bipolar disorder, depression, mania, bipolar. So we have no idea. And I think in order to understand the brain and why it brings forth and contributes to consciousness, we need to understand psychiatric disorders. So this is why I take the psychiatric disorders here as a starting point to understand the mind.
Okay. Yeah, and you spend a lot of you have chapters on both of those disorders towards the end of the book, and you spend a lot of time working up to that by examining some of the fundamental substrate, if you will, of that question, having to do with, well, what is consciousness? What is the self? What is mind? And so there's a lot of kind of wrestling with those basic issues. And you actually are a researcher, and it seems like your tool, to a large extent, is fMRI, which lets you explore some of these questions without needing to have a damaged brain. Is that right?
Yeah, both. I mean, the damaged brain, when you ask these patients, what do they experience? How do they experience their own body? How do they experience time and space? How do they experience their own self? That tells you what must go on in their brain. So, and then you can develop proper experiments in the healthy brain as well as in the diseased brain to test those hypotheses. So for me, it's extremely important to listen to what the patient has to say and ask her or him questions along the lines how you imagine certain neuronal states transforming into mental states.
Yes, yes. Do we have a good definition of consciousness? I know to start things off, you started with a very basic description of consciousness. I want to see, I had a note here about that. That we're awake and able to respond to the environment. So that was kind of a starting place, although your definition expands and expands actually as we go through the book.
Yeah, I mean, ultimately is that you experience yourself as part of the within the wider spatial temporal context of the world. Yeah, and that you experience yourself as located in a particular place, spot in the world, but you still experience your part. You relate to the other, like even via internet, it's a completely different relation, but nevertheless, we somewhat relate to each other.
Yes.
I could only do this because I have consciousness. If I have no consciousness, I'm not able to develop this sort of virtual spatial temporal relationship to you. Yeah, I'm cut off. And when I'm cut off, of course, I don't behave anymore. That's what you see in these patients who lost consciousness, the vegetative state or coma, which I discussed.
Yeah, you you hypothesize two sort of a thought experience. Speaking of speaking of Einstein, a thought experiment, which is to imagine two young people have a motorcycle accident, a man and a woman, young man, young woman, and they both go into what are called vegetative states. And this is particularly close to home, I have to say. When I was a young man, I was in a motorcycle accident. In your hypothetical example, a truck turns in front of them and they hit the truck. In my real life example, I had a young woman on the back of the motorcycle. A car turned in front of us. I flew up in the air, landed on my head and shoulder on the car. Fortunately, I didn't get I didn't get a concussion or brain damage that I know of, and, and neither did the young woman. So your example is close to my experience. So, but I came out lucky. Um, so one of the another element of consciousness, aside from the ability to respond to the environment, is self-consciousness as a kind of unique and particular aspect of what it is to be conscious. That is that I have a sense that I know who I am and that I'm aware of myself. And a person who suffers a brain injury in which they are not self-aware, that does exist, right?
That's really, the self-consciousness is a really hard nut to crack. And indeed, it does exist. I mean, for instance, as I said, in schizophrenia, you can have the feeling that they don't have this self-consciousness anymore, which we usually take for granted. So when you get up in the morning, you look into the mirror and you recognize, and then you feel, yeah, it's me. And despite all the physical changes over the last 20, 30 years, one still says, okay, it's still me. The schizophrenic patient looks in the mirror and says, it's not me anymore. Mm-hmm. So this common sense, or what we take for granted, is somewhat disrupted there.
Yeah. Now, to leap ahead a little bit in the book and the theory that you develop, it seems that in terms of brain structures, that I think what you call the cortical medial system. So I'm not even sure how to picture that. Is it between the two halves of the brain but lower?
Right in the middle.
Right in the middle and going down.
Exactly. Yeah, it's right in the middle, and it is an extension of the subcortical region beneath the surface, the cortex.
Yeah. Would that be the corpus callosum or beneath that?
The callosum is right in the middle, which binds the hemisphere together.
Yeah.
These midline structures are basically on top of the corpus callosum.
Oh, on top of.
Go around, if you want to say so. So let's say this is the corpus callosum. The cortical midline structures go on top of it.
Oh, I had it the other way around. That's good to know. So tell us about the work that you've done there and how you're able to make that connection between self-awareness and no self-awareness.
Yeah, that's an interesting point, and it started with empirical findings, actually. So there are a lot of experiments 10, 15 years ago, and still are, where people compare, let's say, what are the neuronal effects of stimuli related to your own person, like your own name or certain trait adjectives, versus stimuli or tasks that are not at all related to you. Let's say if I show you a picture of San Francisco, it has a high degree of personal relevance to you. I assume because you live in San Francisco, that's what I recall.
Yeah.
If in contrast, I show you a picture of Ottawa, where I live, minus 30 degree and snowstorm, I'm sure it has no relation for you. There's no relevance for you. For me, in contrast, this picture of Ottawa minus 30 snowstorm in winter is highly relevant because I have to survive the winter here. Yeah, and interestingly, these experiments showed that when you compare these two stimuli, that you have particular activity changes in these cortical midline regions.
This was fascinating, that because I had never heard anything like this before. I forget what are the names of the two people, your two hypothetical people? What were their names, just so I can refer to them easily?
Let me just
I could look it up. I think it was Julie and
the two people. Loss of consciousness. John and
Julie, was it?
John and Julie, yeah.
Okay, John and Julie. So I was shocked. Here, John and Julie, they're both in what we would call a vegetative state or a coma. So they seem to have no consciousness at all. And now your image is dark. I don't know what changed, but you were brighter before. Yeah, getting closer helps. And
okay.
And so you're able to. I'm trying to remember how you got the stimuli to them, that they would their brain would respond to stimuli that they knew about. As you know, if it was describe your house, or
Correct.
think about your house and the rooms in your house, then you would see their brain start activating
Right.
as if that's what they were doing.
Right. So some researchers did indeed, if there is, when they have to navigate the house or imagine tennis playing, you see the same regions activated as in the healthy subjects.
And
So
you're saying this to them verbally,
auditory. Or you
auditory, yeah. So they're getting the auditory
so
stimulation of
sends
it,
it autobiographical sentences to them.
yeah.
So auditorily, and then you can see the auditory cortex, the auditory region lighting up so that you know that they really listen. And then you also see some activity in the midline regions. And most interestingly, the degree of activity in the midline regions predicted the degree or the level of consciousness. Meaning the more activity difference between own and other name, the higher your level of consciousness.
How can you say the higher level of consciousness if they are still in a vegetative state?
Yeah, because we measure that with a behavioral scale. And you can have different stages. You can have a vegetative state, you have a minimal conscious state, minus minimal consciousness state, plus. So you have a different sort of grading or stages of level of consciousness.
Now, this would make it ethically a very challenging decision to pull the plug, right? This is something that people face, relatives. Is this person dead or not dead? If the brain is still being active.
Yeah, that's for sure. It changes all our views of the model of brain and of the self and poses real ethical decisions. Yeah. It is clear that the brain is still functioning in these ways, in these patients, in certain ways, but it's not processing the stimuli in such a way that they can be associated with consciousness. And we're currently trying to find out, and apparently this self-related processing, as we call it, stimuli relating to your own self, like the own name or the picture from San Francisco for you, or for me, the picture from Ottawa, that this processing capacity is highly relevant for consciousness. Why and so, we don't know. And that's a very interesting thing, because ultimately it leads back to some philosophical theories where say maybe the self is the driving force of consciousness. And this is not only philosophically relevant because it will also give us a new understanding of the neuroscience of the brain, and also clinically, because maybe we can use these kind of self-related stimuli as clinical marker for the level of consciousness, whether the patient will wake up or not.
Let me jump to a question that I had. You know how in hospitals we have the crash cart? Somebody has died, they rush in, they give electrical shocks to the heart to stimulate it, and the person comes back. And your book got me to wondering if the same thing might be done at a cortical level to somehow shock the brain back into a fuller range of consciousness.
That's a difficult question. So clear is that in these vegetative state patients, they have huge brain lesions. I mean, it's unbelievable. They have very wide ventricles. It's unbelievable. The brain lesions are quite huge. How that exactly is related to the loss of consciousness, unclear. How that predicts the possible recovery. And there are some experiments where they don't do electrical shocking, but they do transcranial magnetic stimulation.
I was wondering about that very thing, yes.
Or direct current stimulation.
Yeah.
So indeed, there seem to be some positive findings, but not as clear-cut as one would like to have. It's also probably because each patient is different. There's a huge variety or heterogeneity among patients.
Yeah. And when you talk about these lesions, that would probably depend upon the condition. I would think lesions would take some time to develop. And so, for example, John and Julie, I wouldn't expect that their brains would necessarily have that kind of physically observable by the naked eye kind of changes.
Right. You need indeed some high resolution imaging techniques. And of course, we hope that we can improve the resolution. With better imaging techniques, you see more. Yeah. And definitely we are just at the beginning.
And another thought I'm having as we were just speaking is that these levels that you talk about, it seems that's likely to have some implications for the law as well, right?
Yeah. Yeah. No, I mean, for sure. I mean, if we can, as neuroscientists and clinicians, can give exact markers, I mean, when you have cancer, you can have clear diagnostic markers for the kind of prediction you have. Yeah.
Okay.
Certain cells, certain number of lymphocytes, and so on and so on. And according to that, you select the chemotherapy. According to that, you stage your prediction. Yeah, and according to that, you tailor your treatment. If you say you have certain cells way too many, treatment makes no sense anymore. And that's a decision with high-ranging ethical implications.
Okay.
I hope at some point, let's say maybe in 10, 15 years, I hope I distinguish different levels of neuronal mechanisms, neural predisposition, neural prerequisites, neural correlate, that maybe in 15 years we have 10, 15 different levels.
Yeah.
So
Now,
it's a much more fine-grained.
Now, one of the things that seems to characterize the higher levels is you point out that consciousness, what we would consider full consciousness, is a global phenomenon. It's a whole brain phenomenon rather than we might have thought that, oh, there's this little place in the brain that's the seat of consciousness. But you and others have found that it's really associated with massive activity across the whole brain.
Right. Yeah. No, it's no doubt. It's not. I mean, when you look into the history of neuroscience, it always oscillates back between a very localization of mental function in specific regions or networks, or the more holistic approach, the whole brain. And it is no doubt that consciousness, the whole brain is involved.
Yeah.
And you need the whole brain. Even if only certain regions are activated, that activation of those regions depends on the rest of the brain.
Mm-hmm. Mm-hmm.
It's no doubt. So it's a holistic phenomenon, if you want to say.
Yeah. Now, another important concept experimentally that you've been working with is the idea of the resting brain. And so, of course, that raises the... And the resting brain, as you use it, is not a dead brain with no activity at all, but rather, as you point out, actually a lot of activity. So how do you decide what is... And that sort of becomes the baseline in your model for a lot of your work is the resting brain, to kind of compare it to the resting brain. So what do we know about the resting brain?
Yeah, a good question. So you can call it resting brain, as you pointed out very nicely. It's really a deceiving term. Yeah, it deceives you because it's never at rest. If your brain is at rest, meaning zero, then you're brain dead. So that's something I think neither of us wants.
Right.
So you call it sort of spontaneous activity. And it is clear this spontaneous activity has always been somewhat on the sidelines in neuroscience, but the predominant view was always the brain shaped by the stimulus or task, external task evoked in that activity. But now it becomes more and more clear that this spontaneous or resting state activity has certain features which are very central. And it has a certain temporal feature. It has continuous fluctuations in different frequency ranges from very slow, very fast, gamma rhythm might be known. And it also has a certain network structure, different networks and regions which are very extensively characterized these days. But however, the exact function and role of this spatial temporal structure as sort of a virtual spatial temporal structure is really unclear. So my hypothesis, based on findings, based on what I see in psychiatric patients and in neurologic patients and healthy subjects, is really that this spatial-temporal structure is central for mental features and the subjective nature. So it is the spontaneous activity which adds something to your perceptions, let's say, of me, and that makes you have a certain feeling, certain experience. So when you perceive me, I would probably investigate your activity prior to your perception of me and see how much that impacts.
Now, I would think that the resting brain would relate to the very deep structures. I was wrong about that with the CMS, the cortical system. But wouldn't we be talking about things down in the deeper structures, the thalamus and so on, that part of ourselves that runs automatically?
There's the spontaneous activity is throughout the whole brain. There's no doubt. Every region has spontaneous activity, including subcortical and thalamus.
Okay.
However, there are certain differences. Let's say, for instance, in the degree of change. There's a lot of change in the amplitude. We call it variability or temporal variance. But in the neuronal spontaneous activity, particularly in the midline regions. Whereas in subcortical regions and sensory cortex, there is less change and variability in the spontaneous activity.
So,
and
I'm thinking of a metaphor of a car idling. Would that be an apt metaphor, that your car is idling, it's ready to go if you step on the accelerator, if you turn the steering wheel, but in order to be ready to go, it's got to be turned on and be idling in an idle state?
Yeah, one can say that. So I usually like to go even stronger. Let's say, imagine you open your garage door and your car moves back and forth. Yeah, it doesn't stand still. Yeah.
Oh, okay. Yeah.
Movement. It has a time point, it changes, space point, it changes. So, and now what do you do?
Well, if we ever develop a biological car, right,
yeah,
then we would expect
true.
that. That's characteristic of biology. Yeah.
You can go to Google with that idea. Yeah. So what do you do now? In order for you to enter the car and to make the car move into the direction you want, you have to somewhat adapt. So you have to come at the right time, at the right point in time and space, so that you can open the door, get into the car, and steer it into the direction you want.
Now, that's getting at another thing that I thought was very interesting towards the end of the book, where you start talking about rhythms, the temporal aspects of the brain. And we've some years ago, there was a book called Biorhythms that was quite popular, and it really brought into popular awareness the fact that we have these different rhythms going on in our body. We've got the menstrual cycle, we've got the sleep cycle, we've got the cycles within the dream, the 90-minute cycle of REM sleep, and so on. And you point out that in the brain, there are lots of little cycles that are going on that are very important. We don't know all of them, but they're going to have an impact on things that we call mental illness, and probably on all of the drugs that we use. You know, we never know if I give this person a drug, how are they going to respond? It may be just the reverse of the other person I gave it to, and so on. There's all this variability between human beings, and so a lot of that variability is temporal and is happening in the brain.
Yeah, correct. I mean, there are continuous fluctuations in the activity, as you said, cycles, and these fluctuations can occur very fast, let's say 50 to 60 hertz or even faster, or very slow in 0.01 hertz, where you have extremely long cycle durations, like 50 seconds or 100 seconds. And interestingly, the strongest power in the brain lies with these very slow frequencies fluctuations. So the brain spends a lot of energy and power on the slower stuff, not so much on the faster stuff, which is somewhat counterintuitive. And we try to make sense of that. So we really go into these particular slower or infra-slow frequency fluctuations, as they are called, with long cycle durations, 100 seconds. And we consider them the temple basement of the brain. Now, consider the analogy to a house. If you look at the very ground floor, the basement has to carry all the load of the upper floors.
Yeah.
So particularly if you build a skyscraper in New York or San Francisco. So it has to be very stable, yeah, against the wind and all kinds and storm and all kinds of things.
Yeah.
So meaning if your basement cracks, everything else, all the upper floors will also crack and ultimately fall down, even if the floors themselves are proper functioning. So if your basement, so that's why we assume, so the basement, the very infraslow, may provide a certain sense of stability to the brain for the rest of the brain. And if these are themselves altered, then you have problems.
So, yeah, so this helps make sense for me of a statement that you made in the book that I thought was rather strong, which basically said you speculated that the major mental disorders, such as depression, schizophrenia, and so on, might have to do with a problem in the resting state of the brain,
Yeah.
which is kind of, as you say, is kind of the reverse of what we would first think of. Oh, this has got to be problems with the higher order thinking.
Exactly. Yeah. So that's exactly, you said it very nicely. So this is a heritage of Western philosophy. Cognitive mental features are higher order features.
Mm-hmm.
It's the highest pinnacle are features of the mind.
Mm-hmm.
They cannot be features of the body because we don't see them. So there must be features of something higher, like, and you see I illustrated here with my hands, of the mind. That goes back to Descartes' dualism, and if not further back in philosophy. And interestingly, this somewhat has been conveyed to neuroscience. Yeah, so that resurfaces that, okay, these are cognitive disorders, neurocognitive of cognitive function.
Yes.
But when I see my patients, and when I see now more and more data coming in, maybe these are not higher order cognitive dysfunctions, but these are dysfunctions, not dysfunctions of the higher floors of the building, but basic structural dysfunction of the ground floor.
Yeah.
And if your ground floor is altered, everything else, / the higher order functions, emotions, cognitions, social functions, motor actions, perceptions are abnormal. That's what we assume. We just had a paper in PNAS on exactly this in bipolar disorders, where we showed that in certain networks in the brain, they have abnormal balance in the resting state, in the variability, in exactly these very slow frequency ranges. Yeah, in exactly the temple basement.
Okay, that's what I was going to ask you. Is what I understand the metaphor, but what happens in the science? So you say the science shows that there's a disruption of the rhythms of those very long frequency resting state.
Exactly. Yeah, exactly, of those rhythms and in the variability. There's not enough power. Yeah.
Uh-huh.
There's not enough power, meaning your basement is not strong enough.
Okay.
So it affects everything else.
Okay. Okay, let's see. I'm looking at some of the questions I thought about to see where we should go next. So, one thing is going back to consciousness. You say that another characteristic of consciousness is that it has to have contents. Say more about that.
Yeah. So let's say if you had done neuroscience 30 years ago and you had mentioned you do the neuroscience of consciousness, everybody would have looked at you and said you're crazy. So because consciousness was not a subject matter of neuroscience. It was considered subjective and / not eligible for objective neuroscientific research. Mm-hmm. That fortunately changed a lot with Francis Crick, who was very interested in the DNA, the founder of the DNA with Watson. And he was very interested in consciousness, and he developed with Christoph Koch together then a series of papers, and they spoke of the neural correlates of consciousness. And that meant, and then some philosophers like David Chalmers did that too, that basically meant the sufficient neural mechanisms of the contents of consciousness. Because when you're conscious, it's about contents. So, but now, when you see, for instance, here John and Julie in my book, the two who lose their consciousness, a vegetative state, they lose the contents, but also they lose the level of consciousness. They have no arousal. They cannot change their arousal. So that led to the view of maybe consciousness has yet another dimension, not only contents, but also level. And maybe those two have different neuronal features.
Now, this is making me wonder about Buddhist meditators, advanced Buddhist meditators, and some of the states of consciousness that they're able to produce that they describe as pretty much free of content.
Exactly. So this is
so what does that do to your theory? What does that make you think?
This is a beautiful example, because this is exactly. So these people have still, I'm often in Asia, in China, and Taiwan, and Japan, so I'm often confronted with that. Indeed, so these people indeed have still consciousness, but they have no content, because the cognition of the content somewhat disrupts you. So what do these people experience if they don't experience content? I would argue that they experience a certain form or spatial-temporal structure. Pure time, what William James called the stream of consciousness. You immerse yourself in the pure flow of your continuous flow of time or your frequency fluctuations, and do not attach a particular content to it. So you get not stuck by this content. Just yesterday, I had a severely depressed patient who told me in the depression, he glues himself to contents and then just ruminates about this content, and that drives him crazy and makes him depressed. Mm-hmm. The only thing which he said helps him is that he knows it's a continuous process and it will go over. Yeah, it will vanish. And that means, and he learns that from meditation, the flow will go on and it will go past his current attachment to specific.
Yes. Now, that's a lot about what a mindfulness meditation tries to train people to do, is to not get attached to, as you say, attached to the contents, and to kind of develop a larger view. Okay, waves come and waves go, and the experience. The experience of what people refer to as enlightenment, which I personally don't subscribe to the idea that a person can become enlightened permanently, but I do believe that people can have moments of what's called enlightenment or illumination, and the chief characteristic of that is, interestingly, flowing from this non-attachment is a feeling of connectedness to everything.
Right.
Connectedness to the universe.
Right. Yeah, that's probably that. I would probably, the way you described it, I would probably share that. And ultimately leads you that consciousness, and actually many schizophrenic patients have exactly this experience. Yeah. Their own sense of self is dissolved somewhat. Mm-hmm. Mm-hmm. They become unified in their experience with the universe and get this transcendental, spiritual like experience.
Yeah.
And I would probably speak here of a certain form of consciousness, a certain structure. You have a certain spatial temporal structure which connects you with the world, and you're part of that. So I would associate consciousness not only with content and level, but also with the third dimension, with form or structure, which is a very traditional concept which goes back to Kant in philosophy.
Yeah, yeah. Looking through my notes here. we've covered a lot of what I have in my notes here. Let's see here. One thing that is I think that I started to think about as in your discussion about self is that I've recently become aware of the extent to which self is a social construction.
Mhm.
In other words, we tend to think of self as being it's all in here. It's all in the envelope of my body or the envelope of my head. If we get really holistic, we say it's distributed not just in my brain but throughout my whole body. Uh, but the evidence is suggesting that other people support what this thing that we call self, the expectations they have of me and how I've behaved in the past, and they sort of more or less the demand characteristics of the situation are that I continue to behave in that way. And that's one of the elements of my experience of self.
Mhm.
You want to comment on that or add to it or subtract from it?
Yeah, I mean, as you said, traditionally philosophers considered the self as a highest order mental or cognitive entity. Yeah, and that has been often preserved in neuroscience as a cognitive view of the self in specific higher order cognitive regions like the prefrontal cortex. Here, when I show here. That has been somewhat criticized by other people who say maybe this it's not only the brain, but it's also the body. So then they speak of an embodied self. And the self is not only cognition, but it's also action and perception. My view of self goes even more basic and deeper. So I would argue what makes it possible that you have this relation between brain and body, it's ultimately that your brain is intimately connected with the world. So how your brain processes certain stimuli from the environment. Because as you said at the very beginning, you said it very nicely at the beginning of the interview, the resting state or the spontaneous activity of the brain provides a certain baseline or standard. And every stimulus is set or compared or matched against this baseline.
Hmm.
So if the baseline is very high, the same stimulus is processed in a very different way, and when compared, the baseline is very low. So meaning your brain can very much impact via its resting state how stimuli are processed. And that's what I ultimately mean by degree of self-relatedness. So it's a very basic function between brain and world, brain and body, because the stimuli from the body are also filtered by the brain
Yeah.
and its resting state. So basically it acts really like a filter. If the filter has very big holes, everything can go through. If the holes are very small, nothing can be processed. Meaning then that's probably in depression the case, because the resting state is so high that the stimuli cannot change it, then you feel disconnected from the world, for
Okay.
instance.
You have a really nice formula where you say mind equals brain plus genes. We haven't talked about genetics, but mind equals brain plus genes plus interactions with the environment.
Yeah.
So that gets the environmental piece in it. You just made reference to depression, and let's talk about that some more. I was really intrigued by some of the information in there. For example, you said that um, you referred to two principal ways that we have of intervening in depression right now. One being the use of SSRIs, drugs, and you say those suppress serotonin, that the depressed person suffers from an excess of serotonin, which I
Yeah.
didn't know. So that's interesting. But you point out that those drugs take maybe 60 to 90 days or 30 to 90 days before they really kick in, which we've known about that part, and that's got a big problem because a person might commit suicide before they even get the benefit of that. Um, so that's an effective intervention, but very slow. And then you refer to ketamine, and again, like my motorcycle story, that's close to home because one of my sons has been suffering from neurological pain, and as a result, we discovered that ketamine is used not only in depression but also to treat neurological pain. So he went through a 30-hour infusion, 30 hours of getting this ketamine into his bloodstream. We just did this just a couple of weeks ago. He seems to have responded to it really nicely. So the advantage there, and if I understood it, ketamine raises the level of glutamate, which sort of is a up leveler. It increases the excitatory activity of the brain. Is that right?
No, it's rather the opposite. It blocks an apparent excess of glutamate. It has certain doors or receptors, as we call them, and it rebalances the relation between excitation and inhibition towards inhibition.
Oh, towards inhibition. Yeah, that's one of the paradoxical things, I think, in neuroscience is that we often discover that the value of inhibition, right?
Yeah. It's really this excitation-inhibition balance, as we call it, is mediated by two central substances, glutamate, you already mentioned, which is mainly excitatory, and GABA, which is mainly inhibitory.
Okay.
We don't really know at this point in time how this balance exactly functions. We know a lot on the cellular level, but we don't know much on the regional and network and whole brain level. And of course, obviously, for pharmacological intervention in psychiatric disorders, as you mentioned, in depression or neurological pain, we need to understand the exact balance. Mm-hmm. So you might have, let's say, the same level of excitation, but you might have different levels of inhibition. So the same level of excitation will have different effects in the presence of different levels of inhibition. That's the balance is relevant for the brain's neuronal. Mm-hmm. But the details of that are elusive. So.
Okay. Is there anything more you want to say about depression before we move on to schizophrenia?
Yeah, I mean, what happens in depression, there's more and more evidence, and that sort of your resting state, particularly here in these midline regions, is abnormally high. There's too much variability. So you have all these racing thoughts. Because there's too much activity going on, too much internal thoughts are initiated, and those you cannot escape. And then, of course, that goes at the expense of your external orientation. So you're just completely consumed by your internal thoughts, so all your attention, cognition is directed towards that. Whereas at the same time, you feel completely disconnected from the external world. And of course, that makes you sad.
What about the, we have bipolar. So what's going on there? I mean, there are all kinds of theories psychodynamically, about what that's about. But we know that lithium is important for the manic part of it. What's your understanding at this point from neuroscience of that alternation between depression and mania?
Yeah, and so, as I said, in the midline region in depression, you have too much activity, you have too much variability. In mania, it seems to be the other way around. There's not enough activity, there's not enough variability in the amplitude. And just yesterday, I had a patient who told me, in the mania, I'm not thinking. That's exactly what you have predicted on the basis of the findings, which we found in manic patients. Not enough activity, not enough variability in this midline region.
I'm not thinking, I'm just impulsive, I'm just doing?
Exactly. That's what the patient said very nicely yesterday. So he said, I'm just scanning the environment, constantly scanning the environment, just looking impulsive, following this, you do this, so I follow this, and so on and so on.
I'm surfing, right?
You're surfing, exactly. Surfing, you're just gliding, but at some point it becomes too much. That goes along that in your sensory motor network, in your regions, you have too much variability in your brain. Yeah, so there's too much going on, so it constantly picks up external stimuli and follows them, and then this one and this one. So that's a predisposition by your resting state. That's why I like to speak of neural predispositions of these disorders or of consciousness.
Yeah. Now, we've been talking a lot about consciousness and sort of levels of consciousness. What about the psychodynamic unconscious, the unconscious of Freud and Jung and their successors? Does your work comment on or shed any light on that notion that what we know that the unconscious isn't dead, right? We agree on that. It's not a state of deadness. What can you say about this concept of the dynamic unconscious, one that is actively dealing with hopes and fears and traumas and all of that?
So you may remember from my interview when I said this notion of self-relatedness, where you in a very basic sense, relate certain contents from the environment to your own brain and its spontaneous or resting state activity. And that the spontaneous or resting state always serves as a baseline, as a standard. That's one thing. At the same time, it's very clear, and we had a study last year on that early childhood trauma or early life events are somewhat encoded or encrypted in the spatial-temporal structure of your resting state. For instance, in entropy, in the degree of disorder. Meaning, the more traumatic life events you had as a child, 20 years later, the more entropy you have in your resting state of spontaneous activity. So I now put these two observations together, meaning that the kind of structure you have in your spontaneous activity is strongly biographical. It's biographical and self-related. So self-related means what is important to you. Mm-hmm. Biographical means of you, your past life.
Okay.
And now these are two central dimensions of the dynamic unconscious. Yeah. So that's where you can make a bridge to psychoanalysis.
Okay.
The contents in your dynamic conscious tells you something about yourself, your ego, and your biography and your past history.
What about the dreaming state? Would you say that is that getting close to the resting state? Is there a similarity between those two?
Yeah, that's a very, very interesting question, because in dreams you have consciousness. So you need to explain that just your resting state itself, independent of any external stimuli or contents, can have consciousness. That's a really hard nut to crack for many cognitive people. So my assumption on all of this is, in order to have consciousness, let's say, in order to associate consciousness with certain contents, you need a certain degree of change in your neuronal activity. That change can be either triggered by external stimuli in daily life. So when I see you, you trigger a lot of change. That's why I become conscious. At least I think so. And maybe in dreams, you have also certain biochemical changes, let's say, related to acetylcholine, which Alan Hobson pointed out, that these changes are strong enough to trigger spontaneous consciousness. So ultimately, it's the same. You have, for instance, the same in auditory hallucinations. You suddenly hear internal voices in the schizophrenic patients, just on the basis of your resting state activity. So you have a certain degree of change, and that associates the respective virtual content coded in your resting state with consciousness.
Okay, what more do you want to say about schizophrenia and in the context of the neuroscience that you've been doing?
Schizophrenia is so complex, you can't imagine. You can't imagine the amount of literature.
I know, huge.
And you have the patients in front of you, each one is different. And there's a very, very basic disturbances. There's been enormous amounts, all kinds of literature about schizophrenia, and we haven't really understood. Meaning we haven't found the key to that. So for me, it is really this very basic, again, I come back to the self-relatedness. So you set a stimulus, an external stimulus from either the body or the environment against the baseline of your spontaneous activity. And by that, you change how the stimulus is processed. So it's a very basic process. It's the first encounter of the stimulus with your brain. And my hypothesis is that this very basic, most basic process is changed in schizophrenia for whatever reasons. And then, of course, any kind of subsequent processing, sensory, emotional, cognitive, is abnormal. Yeah. So these patients have major perceptual abnormalities. They perceive things much more intense. The stimulus is no longer filtered. There's not enough inhibition. Speaking of inhibition, and that's probably due to the fact that they cannot be filtered, not set against the baseline. Then there's this relation of self-relatedness missing, what you take for granted, that you're related to the world. You know, when I do this, what it means. You know what it means when I shake my head or when I do this or nod my head. For the schizophrenic patients, all this is questionable. He doesn't know. So, of course, then he thinks, why is the guy there on Skype constantly doing this? What does he want to do? Or maybe he wants to kill me tonight at 8 p.m.
Does this imply any sort of an intervention? You know, a cure, a treatment?
Yeah, I mean, my main idea is really to find out what is wrong with the spatial-temporal structure of the resting state. Yeah, why can't it fulfill this function anymore, that it processes stimuli in a self-related way? Yeah, that it can serve as reference or standard or baseline.
When you say spatial temporal, that gets a little confusing for me. What exactly do you mean?
So by temporal, I mean, remember you had the cycles, the
Yeah.
frequency fluctuations. By spatial, I mean different networks. Sensory network, default mode network.
Okay.
Yeah, so
Yeah,
that's what I mean.
Okay, good.
What is wrong with the function of this spatial temporal structure? That it cannot serve its usual traditional role as baseline, standard, or reference.
Yeah.
Any kind of external or internal stimulus.
So can you imagine a way to intervene neuroscientifically in the future that might be effective?
Let's say I gave you the example of depression, that you have too much variability, too much change, too high activity in these midline regions here. So maybe you can sort of inhibit the variability. Yeah? That don't have these racing thoughts. Or depressed patients usually don't walk, they don't move. Yeah? They sit there in the corner and are depressed. We call this as psychiatrists psychomotor retardation. That seems to be related to decreased change and variability in the sensory-motor networks. So maybe we can stimulate that. But each patient is different. So that's what we're trying to do and what we're targeting in the future.
Yeah. Okay, let's get a little bit more speculative here. Are animals conscious?
Yes, I think so, but not with the same degree of spatial-temporal extension as us. So I would look at their resting state. I would look at their spatial-temporal range, so how slow the frequencies are, how fast they are. And from that, I would predict the degree of spatial-temporal extension. So I discussed some of that in my major academic books, Unlocking the Brain, 2014.
Okay. Are there people who are working on that, trying to understand animal consciousness?
There are animal studies, and I think it is a great topic, but how much you can experimentally tackle that. I know that there's some about self-consciousness, with monkeys recognizing themselves in the mirror.
Yeah.
But otherwise not.
Yeah.
Not aware. I'm also not an expert on that.
That'll be what, the next 100
I'm
years?
not an expert on that. So there might be literature doing that, yeah, but I'm not aware of that.
Yeah, and what about plants? Are plants conscious? I read plants. I read something in the New York Times just the other day. I didn't read it that closely, but it seemed that plants were being somewhat planful in terms of whether or not to spread their roots depending upon the quality of the soil that they were put in. And this was an experimental paradigm. So it would suggest that, and reading about one of these conferences that I didn't go to, but maybe you did, there's a movement towards something called panpsychism, right?
Yeah.
That consciousness is everywhere in little tiny atoms of consciousness.
Yeah, that's the latest rave. I think this is, so 10, 15 years ago, it was all about physicalism, materialism, that consciousness is in physical properties. Now they say, okay, now the philosophers say it's no longer in physical properties, but maybe it's in psychic properties. I think it's variations of the same. What you need to understand is, I think there are no specific properties, intrinsic properties, either mental or physical. What there is relationships, there is structure. There is the structure between world and brain. Based on the spatio-temporal features of the brain, that relation between brain and world can be different in different species. So we need to have more sort of a structural or relation-based approach, I think, to address mental features. And that's exactly when you look at consciousness. This is what consciousness is about. You experience yourself and events in the environment as part of the world. So how is this possible, this your own situatedness or situation within the world? Yeah? So I perceive you as the Gestalt psychologist spoke about figure and background. Yeah. So the world is always the background, serves as the background for the figure / the content. And that is, for me, the construction of a virtual spatio-temporal structure between the world and myself and the event which I perceive.
So do you believe that artificial intelligence could get to the place where consciousness would be achieved in a machine?
If it has the right neuronal code and can cracks the code of the brain, that it's what I would argue is a spatio-temporal coding, and it can reconstruct this virtual spatio-temporal structure between, let's say, the machine and the environment, and constant dynamic change, I would say it's not principally excluded.
Okay, interesting. Well, is there anything else that you would like to add that I haven't thought to ask?
I think as you said, we covered a lot of ground. I mean, the only thing, ultimately ends up where you started with the heart problem. Yeah.
Why
is there consciousness rather than non-consciousness? I would argue because there's always spatio-temporal structure. There's always a relation between world and brain and world and body. We cannot escape that. That's the way our brain functions by default. So we have no chance of escaping that. That's the way the brain functions by default.
Okay.
Yeah. So, and ultimately then we should not speak of a mind-body problem, but of a world-brain relationship problem. It might be better formulated than getting into all the metaphysics of the philosophy.
Okay. We'll save that for another time.
Save that.
Dr. Georg Northoff, I want to thank you for being my guest today on Shrink Wrap Radio.
You're welcome. Thank you very much.
Yeah.